Now next topic, that is energy stored in a capacitor. See, suppose initially the capacitor that is uncharged, and now we are charging it. So here, when we charge it at that time, suppose we deposit delta q dash delta q dash delta q dash delta q dash amount of charge on the capacitor. Then for that we have to do work, and that work done will be stored in it in the form of potential energy. Here, how the charging process is done. So initially when capacitor is uncharged, it implies that both the plate of the capacitor, that is with 0 coulomb net charge. Then here what we do, from plate number 2, suppose delta q dash amount of positive charge is transferred to plate number 1. So now on plate number 1 there will be delta q dash charge, and on plate number 2 there will be minus delta q dash charge, because initially plates were neutral. So if delta q dash positive charge is removed, then minus delta q dash charge will be free. So in this way, delta q dash delta q dash delta q dash delta q dash charge is transferred, and resultantly if charge on capacitor deposited, that is q, then in this process whatever is the total work done is stored in it in the form of energy, and that is called energy stored in a capacitor. Clear the concept? Now suppose at a particular instant the charge on the capacitor, that is q dash, and at that instant delta q dash amount of charge is transferred from plate number 2 to plate number 1. And at that instant, suppose the potential difference between two plates, that is V dash. Then we know this thing, the work done, that is equal to delta q dash into potential difference. But here V dash, that we can write q dash by C, because at that instant the charge on the capacitor, that is q dash, and capacitance of capacitor, that is C. So the work done delta W, that is q dash by C into delta q dash. Clear to all of you? Now this particular work done delta W, that is equal to q dash by C into delta q dash, that is given by the equation delta W equal to 1 upon 2C into q dash plus delta q dash square minus q dash square. Now see, take this equation delta W equal to 1 upon 2C into q dash plus delta q dash whole square minus q dash square. Now simplify this equation. 1 upon 2C into bracket q dash square plus 2 q dash delta q dash plus delta q dash square minus q dash square. So that is equal to 1 upon 2C, q dash square cancelled. So into bracket we can write here 2 q dash delta q dash plus delta q dash square. Now take this 2C inside the bracket. So for first step 2 cancelled. So delta W, that is equal to Q dash by C into delta Q dash, plus second term delta Q dash square by 2C. Now here the charge transferred from one plate to another plate, that is infinitesimal small one. And therefore, here this delta Q dash square, that will be more smaller one. And upon 2C, so this entire term that can be neglected compared to the first one. So neglecting this term, now we can write resultantly delta W, that is Q dash by C into delta Q dash. So that is our this equation. So in this way, we can say this work done delta W Q dash by C into delta Q dash, that is represented by delta W equal to 1 upon 2C into Q dash plus delta Q dash whole square minus Q dash square. Clear to all of you? Now see, initially capacitor was uncharged, and when very first we transfer the charge delta Q dash from one plate to another plate, then in that particular process, the work done delta W, that is 1 upon 2C, final charge, that is delta Q dash square of it minus initial charge 0 and its square. Then after, again we transfer delta Q dash. So in that process, the work done delta W, that is equal to 1 upon 2C. Now already delta Q dash was there, and another delta Q dash is transferred. So total final charge, that is 2 delta Q dash square, and initial was delta Q dash, so it's a square. Then again delta Q dash is transferred. So delta W3, that is 1 upon 2C, final charge 3 delta Q dash square of it minus initial charge 2 delta Q dash square of it. Then delta W4, 1 upon 2C, then final 4 delta Q dash whole square minus initial 3 delta Q dash square. And then finally, when the total charge deposited on the capacitor Q, so delta Wn, that is 1 upon 2C, final charge, that is Q, it's a square, minus the initial, that is Q minus delta Q dash, square of it. And now if we take the summation of all these, then here you can see this thing. If we sum up all these terms, then for this first one, delta W1, this 0, and for this last work done delta Wn, Q square will remain, and rest all the terms will be cancelled. So finally we can write the total work done, that is the summation of all these work dones, sigma delta W, and that will come to 1 upon 2C into Q square minus 0. So finally we can write that W, that is equal to Q square by 2C, and this will be stored in it in the form of energy. So we can say energy stored in the capacitor, that is Q square by 2C. Clear? We can calculate this energy stored in the capacitor using integration also. See, at a particular instant, we calculated the work done to transfer the charge delta Q dash from one plate to another plate. That is delta W equal to Q dash by C into delta Q dash. Q dash, that is the charge on the capacitor at that instant. Now in this way here, actually delta Q dash, delta Q dash, delta Q dash are transferred from one plate to another plate, and capacitor is charged from 0 coulomb amount of charge to Q coulomb amount of charge. So total work done W, that is integration delta W 0 to Q. Substitute here value of delta W, that is 1 upon C. It is taken outside the integration because it is constant one. Integration 0 to Q, Q dash delta Q dash. So 1 upon C, integration Q dash delta Q dash. So that is Q dash square by 2 and limits 0 to Q. So take these two outside this one. So 1 upon 2C. Now Q dash, that is equal to Q, first upper limit, then minus Q dash equal to 0, the lower limit. So 1 upon 2C into Q square minus 0. So total work done W, that is Q square by 2C, and that is stored in it in the form of energy. So we can write the energy stored in the capacitor, that is Q square by 2C. Simple. Clear? Now energy stored in the capacitor U, that is Q square by 2C. But Q, that is equal to CV. So we can write C square V square by 2C. Here 1C, that is cancelled. So we can write the equation of the energy stored in capacitor, that is half CV square. Now C, that is Q by V. So here 1V, that will be cancelled. So we can write another equation for the energy stored in capacitor, that is half QV. So you can use any of the equation for the energy stored in capacitor. Clear to all of you?